Hi guys, so in this video I picked out a pretty difficult implicit differentiation question, but what makes this very unique is that x is actually a power. We need to somehow bring it down so it's no longer a power. Now that might seem familiar to you guys, and it should sort of point towards using the ideas of logarithms. So what helps is applying the power of, or even applying ln to both sides of the equation. So let's do that. Ln of y equals ln of 2 to the power of x. Now, why do we do that? It's because when we apply logarithms, we can actually use a rule where we take the power as the coefficient. So we can say that it's now equal to x ln 2. And now that it's a coefficient, we're able to sort of use some sort of differentiation method. Now, you have to be very careful when differentiating variables of y with respect to x. For example, if you're differentiating y squared with respect to x, you first differentiate as normal, so it becomes 2y, but then you have to multiply onto it dy dx. In a similar way, ln y will differentiate to 1 over y, but then you have to multiply onto it dy by dx. Let's do the same on the right hand side. So x ln 2, don't get confused by the ln 2, honestly it's just a constant. So if you have like 5x, it would differentiate to 5. In the same way, x ln 2 would just differentiate to ln 2 because it's a constant. From there, I'd recommend you multiply both sides by y, so we get dy by dx is equal to y ln 2. You can replace y with 2 to the power of x and then say that it's equal to 2 to the power of x ln 2. And that's what matches to part A of this question, so that's everything you need to do there. Let's now move on to part B, which is quite difficult itself. Find the equation of the tangent to this curve at this point. So what is a tangent? Let's briefly draw a curve and just remind you guys. So if you found a tangent to this point, it's a straight line that matches the gradient of the curve at that point, so it looks something like that. Now because it is a straight line, that means it's in the form y equals mx plus c. Now there's two variables we need to find. We need to find m, the gradient of the tangent, and c. To start with, we're going to find the gradient of the tangent, and that's given by differentiating. So if you find dy by dx and substitute in the value of x at that point, will give you the gradient at that point. So let's do that. So we're going to focus now on, actually I'm going to do this in a different color pen because everything's getting merged together. If we have y equals 3 to the power of x squared, how would we differentiate this? Well, I'd actually recommend you use the chain rule because it's a function inside of a function. It's x squared inside of 3 to the power of x. So let's replace u with x squared, in which case du dx would be 2x. We can replace y with 3 to the power of u because we're replacing u with x squared, aren't we? And then we can find dy by du. Just a reminder of the chain rule, what we're doing is we're splitting everything in terms of u, and we're saying that dy dx can be found by first finding dy by du and multiplying onto it du by dx. The reason for that is because the du's diagonally, they cancel out, giving you dy dx. So let's do that. Now dy du, when you differentiate 3 to the power of u, using this idea here that 2 to the x differentiates to 2 to the x ln 2, 3 to the u actually differentiates to 3 to the u ln 3. Yeah, it's just honestly the same as method as what I did here, so I won't really bother repeating that. Yeah, in that case, we can now replace u with x squared again. Actually, even before we do that, let's do that at a later stage. Dy by du now is 3 to the u ln 3, and we're multiplying onto that du by dx, which is 2x. Like I said before, we can replace u with x squared, so let's do that. So 3 to the power of x squared ln 3 times 2x, and yeah, honestly we can't really go too much further with this. 2x 3x squared ln 3. Unfortunately, because x squared, what I meant to say is because the x squared is a power, we can't really multiply with the this term here, so we're going to leave it as it is. But that's not really what we're interested in. That gives you the gradient function at any point, but we want the gradient specifically when x equals 2. So let's put x equals 2 into this. It's getting a little bit messy, but putting x equals 2 into this will give you the gradient of the tangent at the point when x equals 2. I'm going to very quickly do that on my calculator. So 2 times 2, and then 3 to the power of x squared, which in this case is 4, and then 324 ln 3. I'm going to leave it in exact format because I don't want to round in the middle of a question. But yeah, now we found the gradient of the tangent is 324 ln 3. We found the m value, that means. So we can say y is equal to 324 ln 3 x plus c. Now we need to somehow find the value of c. Because we know the line crosses through where x is 2 and y is 81, let's put that into this equation. So we have 81 is equal to, well, x is 2, so 2 times 324 is 648 ln 3 plus c. And then we can take away 648 ln 3 from both sides to get c is actually just equal to 81, take away 648 ln 3. After you get to that value, we can now replace c with that value. And we get the final answer of y equals 324 ln 3 of x plus, quite a messy answer, 81 minus 648 ln 3. If you wanted to now put into decimal format, you can, but this would completely get you all marks in this question. Yeah, as you can see, this is quite a unique question and quite a difficult one, which is why I wanted to go through it. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.